Good day, everyone. So today we'll be talking about equations in modular arithmetic. Okay, so we have an example here to find the solution or truth set of the linear congruencies below. Is that okay? So let's see what we can do. All right. Now just listen and follow up carefully. If you have any question to ask after the teaching, drop your comments in the comment section. Is that okay? All right. So we have A, the first one. We have, I think, x plus 1 to be equivalent to 3 in mode 7. All right. So what we do here is this. I love tabular method so much. Okay. There might be other method. Okay. Mathematics is beautiful, of course. There are so many methods in resolving problems. But I prefer tabular method. Makes it easy. So now, what we do is, first of all, you have to take note that that equivalent sign is the same thing as equal to. Is that okay? So you can treat it as equals to, you can treat it as equivalent to, or congruent to. You understand it now? So now, the next thing you do is to observe the 3, that's the number before the mode. If the number before the mode is bigger than the mode, okay, we reduce before we, prepare the table. But since 3 is less than 7, you can go straight to the table now. Is that okay? So in your table is going to contain x, and x plus 1. I mean x plus 1 and then x plus 1. Is that okay? So the x value is going to range from, since it's mode 7, you have 0, 1, 2, 3, 4, 5, and 6. Is that okay? So the plus 1 is a constant. Is that okay? So it will remain constant. Plus 1, 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 and plus 1. Is that okay now? So you have that. Then this x plus 1 simply means you add, x and plus 1 together. So 0 plus 1 is going to give us normal 1. Don't forget we are dealing with mode 7. So 1 plus 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4. 4 plus 1 is 5. Then 5 plus 1 is 6. Is that okay? And then 6 plus 1 is 7, but you don't write down 7, rather you write down 0. Because, we are dealing with mode 7, so 7 divided by 7 is just 1 remainder, 0. So you write down the remainder. Is that okay? So from here, you know, x plus 1 is equivalent to 3. So you quickly trace now from your table where x plus 1 is equal to 3. So we only have x plus 1 equals to 3 in one point, okay, from the row. And that corresponds to 2. You can now say, therefore, x equals 2. Okay, that's basically how to solve, linear equations, in modular arithmetic. So let's quickly look at the B, okay, where we have 6x, being equivalent to 2 mod 3, being equivalent to 2 mod 3. Is that okay? So you will first of all observe the number before the mode. You see that the number is actually less than the mode. So we can proceed now to the table. The table will just contain, x and just 6x in this case. Since we are dealing with mode 3, x ranges from 0, 1 to 3, to 2, okay? So let's multiply. Now 6x means 6 multiplied by x. So 6 times 0 is just 0. 6 times 1 is 6, but in mode 3, that is 0. Is that okay? Because 3 into 6 is, 2 remainder, 0. And then 6 times 2 is 12, but you're going to write down 0, okay? So you agree with me that in this case, you can see, therefore, x has no solution. Is that okay? X has no solution. The reason is that, if you observe critically, you see from the table 6x has no, correspondence of, 2. Because 6x is equivalent to 2, and there's no number from that row that correspond with that. So that's why there's no solution to the value of x in that case. Okay. So then let's quickly look at the C, all right, where we have 2x minus 1 equivalent to 5. 2x minus 1 equivalent to 5 in mode 3. Okay, let's check again. Okay, yeah. So what we do now, if you observe the number before the mode in the right hand side, you agree with me that the number is bigger than the mode. So we quickly reduce that, and that's going to give us 2x minus 1 being equivalent to, if you reduce that, told you you divide the 5 by 3, that's going to give you 1 remainder 2. So we just have remainder 2 in mode 4. I think we have reduced now, so we can go to the table now. So your table is going to contain x, 2x minus 1, and then 2x minus 1. Is that okay? So that's what you have in your table. So since we are dealing with mode 3, x is going to range from 0, 1, and 2. Okay? 2x simply means 2 multiplied by x in mode 3. That's 2 times 0 is 0. Okay? 2 times 1 is 2. And then 2 times 2 is supposed to be 4. We are going to write down 1. Okay? We're going to write down 1. Is that okay? So that's what you do. All right. So quickly, minus 1 is constant, so it remains constant or true. You have minus 1, minus 1, minus 1. Okay, then let's combine now. 2x minus 1 simply means 0 minus 1. All right. 0 minus 1 is minus 1 normally, but since we are dealing with mode 3, you are going to add the multiple, the closest multiple of 3 to convert the minus 1 to 0 or positive. And minus 1 plus 3 is just 2. Okay, so you have 2 there. Then 2 minus 1 is 1 normally. And then 1 minus 1 is 0. Is that okay? So you can now say, therefore, as you can see from the table now, x equals 0. Okay, x equals 0. Since 2x minus 1 is equivalent to 2, when you trace it up, you have 0. So x is equal to 0 in this case. Is that okay? So let's quickly run through the D now. The D now, where we have 6x plus 1 equivalent to 5. Okay, 6x plus 1 equivalent to 5 in mode 11. Okay, so since 5 is less than the mode 11, you can proceed to the table now. So the table is going to contain x, 6x as usual, plus 1, and then 6x plus 1. Okay, so for the x now, you're going to have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Is that okay? So let's quickly multiply this now. So 6 times 0 is 0. 6 times 2 ought to be 12 normally. Okay, but you're going to write down, 6 times 1 is 6. Okay, so you write down 6. Then 6 times 2 ought to be 12 normally, but since we are dealing with mode 11, that's going to be 1. Then 6 times 3 going to give you 7 in mode 11. You already know what I'm doing. So this is 2. When you did very well, this is 8. Then and so on. The 3, and this is 9. This is 4, and this is 10. And then this is 5. The idea is, once you multiply and then you discover that the value is bigger than the mode, you divide that value with the mode and then pick the remainder. That's how to get those values there. So plus 1 is a constant, so it remains constant. Plus 1, all true. Plus 1, like that. Okay, that's going to remain constant, all true. Okay, and then the last column is gotten by combining, 6x and plus 1 together. Okay, that's 0 plus 1. That's going to give us 1. Then 6 plus 1 is 7. 1 plus 1 is 2. 7 plus 1 is 8. 2 plus 1 is 3. 8 plus 1 is 9. And then 3 plus 1 is 4. 9 plus 1 is 10. And then 4 plus 1 is 5. 10 plus 1 is 11. But we are not going to write down 11. That is 1 remainder 0. And then 5 plus 1 is 6. Is that okay? So looking at the table now, you see if this x plus 1 is equivalent to 5, let's trace where we have that. I think we just have 8. Okay? So from the table now, you can see therefore x equals 8. Okay? So that's basically how to solve, linear equations, in modular arithmetic. Do well to subscribe, comment, like for more videos. Thank you.